Yeah, so I'm Jason Arbon. I'm the CEO of Appdiff. I swear I'll figure the microphone out in a second. In fact, would it be better if I take it off, or you guys in the back want it? You want it? Okay. Oh, you don't care? That's the first time I've heard that. Thank you. Okay. Yeah, so I started a little startup company to focus on how do we apply AI and machine learning to software testing. The main reason was I couldn't steal enough money from benefactors at Google and Microsoft to work on this problem, like literally. Because usually in testing, you have to steal money from development and pretend it applies to the product you're working on somehow, right? But instead, I just stole money from venture capitalists and actually told them what I wanted to do. It was an amazing, refreshing feeling. I just told them what I was going to do with their money. So I'd like to start with a, it's not good, it's actually by design. Just a quick little video. You just let it run. So I don't have to talk. But this is actually, I'll talk a little bit over it. This is actually a test case being executed by a combination of machine learning subsets of functionality. So it basically sits on top of Selenium and Appium, and it drives that. So imagine when you write your test code, or your test scripts, it drives Appium to drive the application under test. Instead, we use neural networks and other things to drive it. And just like, you can recognize a hot dog versus a not hot dog, we can recognize back buttons, hamburger button menus, edit boxes. Spend a lot of money on this thing. Here's the test script format. It's super high level. It basically looks like Cucumber. Let's imagine just Cucumber, except the steps below are actually ordered. So I just told that Gherkin Cucumber syntax. So all it says is launch the app, go to a product listing page, go to the cart, and make sure it's empty. Make sure a product wasn't accidentally added to the cart. So that's all we had to type in. Literally, that's all I had to type in. And the rest is actually all powered and run by AI. Why it went gray, I don't know. I'm not that sophisticated. But you can see over here, this is the output of the bot brain, kind of printing out stuff. This is the test script in the middle, and we're driving an Android simulator. It'll launch the app in a second. The reason I want to show this is that like everybody's blah, blah, blah about AI and machine learning and stuff. I just want to start with some actual code that really runs on a real world app. And people believe it works today. It's such a real world app, by the way, that this is chewy. They're poor. Images don't even finish loading in this run. So what the bot's doing right now is it's analyzing every element on the screen, and it cuts the page up, uses the DOM, uses the screen, shot, everything, bunch of neural networks and classifiers, figures out where it is, and then where it needs to go next. So just hit the product listing page. And remember, it could have gone anywhere. Like if we had a random robot, it would have gone anywhere off that first page, right? It actually knows that, guess what? I get the product listing if I click on a thing that looks like a product listing on the home screen, which is a cat or dog. So go back to the home screen, it's heading to the cart. So now again, it's here, there's a lot of optionality, but the machine learning goes, I know that's a shopping cart up top. Shopping carts are highly correlated with landing on a shopping cart page. So I'm going to go there. I'm pretty sure it does it because it's recorded. So click the cart, and that says your cart is empty. And you'll see here in this test script, so it says product list, cart, and verify that this screen has the screen empty on it. So it's done all that, driven it. Little green text at the bottom showed that it actually passed the test case, the regression testing. So again, the AI doesn't know, AI doesn't even know that application, which is awesome. That same test script, because we'll talk about how this works in a minute, that AI can run on every other test. On every other app. That same test runs on Amazon, it runs on Target's app, it runs on Petco, which is even freaking cool. Like the most coolest thing in testing I've ever seen this. I'd ask for applause normally, but it's okay. You're sweet. Can you jump ahead? Okay, cool. So some quick background, like who am I to mouth off about this topic? Because it's a cutting edge technology stuff, it's pretty fancy pants. I'm not actually like, I didn't go to get my PhD in machine learning or anything. So I am an example to show everyone that it's possible that you too can play with this stuff. It's very approachable, and we'll talk about how it works. So my background is I worked at Bing for a while. We talked about, I was asking who's worked on machine learning in the past. Basically, this is kind of a little quick funny story, but back when I was at Bing, it was actually like live search and MSN search back in the day. But we didn't have a search engine that was worth anything, right? So we actually just had to shut the product down. And then 2 Microsoft researchers started playing with neural networks to see if they could build a search engine without 100 engineers, without 1,000 engineers, right? And so really, that's the beginning of Bing, was neural net ranker. So I was testing neural nets before they were kind of hip and cool, kind of during the winter, the AI winter. So we didn't even brag about it or talk about it back then. But we were testing neural nets at scale back then. I worked at Google too, so I worked on personalized web search, which used a lot of classifiers to figure out what your interests are, so they could stack rank web search results to match your interests. I also worked on kind of some large scale testing with the Chrome test automation team over there. And then lastly, I quit and created Appdiff with the sole purpose of trying to apply AI to the testing problem. Because nobody else was doing it, it was frustrating me, and if someone can crack that, it's probably interesting, right? That's why my destiny just kind of led to me working on this stuff. So I stole a bunch of money, like I said, from venture capitalists, so I can pay people to be my friends and work with me. And so all the data stuff I'm going to show you, and all the cool work, was actually done by Joanne and Francis. I just take credit for what they're working on here. Francis has got an odd photo. So we're going to talk on the quick high level. We're going to talk about why AI. Like why is AI interesting for testing? Not just why is it the new hip thing of the moment. We're going to talk about how to apply it to exploratory testing, also regression testing, and also talk about how it kind of enables a new form of testing, which is benchmarking. I call it benchmarking, that's my word, my patented word. But really the interesting thing that AI enables you to do is let you compare one app's quality against another app's quality. Because there's no test team on the planet that has enough money or time to test their competitive apps. So this AI frees you from that. You can actually now compare your app against your competitors. So fundamentally, this is what's going on in the world of testing. And as I see it, I've talked to lots of testers, lots of test teams, and struggle with this problem. The fundamental thing that goes on is the blue line here. This is the complexity of your product, right? Every new feature, someone was bringing it up earlier today, every new feature you add to your product, every new state that you add to your product or your system increases the complexity of your system exponentially, right? How exponential depends on your architecture and how much you share state. But really, every new thing you add could possibly interact with every other thing in your application, right? We all kind of intuitively know this. The problem is that's mathematically exponential growth, right? So what do we do as testers? Like, we're crazy. We go like, I'm going to work really, really hard, and I'm going to write a bunch of test cases to cover everything, right? And I ask testers, how many tests do you have? They go like 100, or they say 500. Sometimes they're really proud and they have 5,000 test cases, right? Guess what? That's linear, right? Like, and guess when in a fundamentally linear activity, because you ask them, how many more are you going to add next quarter? And they go 50 more test cases, and 25 will be automated, right? That's a linear way to approach an exponentially bad problem. So fundamentally, we're never going to solve this testing and quality problem the way we approach it today. So the hope is if we free ourselves of the limitation of humans doing things linearly, then we at least do them very linearly or slightly non-linearly with a bunch of machines, we have a chance to catch up, right? So today, this linear testing activity leaves this huge coverage gap, right? The idea is if we leverage machines that can think like a person, right? They can think like a tester. Some people debate whether that's an amazingly difficult task or a very easy task. But if we can build machines that can deliver 1,000, 10,000, 100,000 times more coverage than we can, because they're emulating humans, we might get close to this complexity and close this coverage gap. I still don't think, to be clear, even at full scale, full AI, everything's figured out and solved, which is not today, it will actually keep up ever or catch up to this feature complexity in applications. That's still another time, another generation. Damn millennials will figure it out. So fundamentally, testing, if this slide's interesting to you, we're in trouble. But testing is fundamentally applying inputs to some black box, which is the product or service, and then measuring that output, right? Comparing that against what we expected it to do. The reason that machine learning and AI of all fields in computer science is super applicable to software testing is that this is what teaching a machine to think looks like, right? It's the same damn thing. We apply a bunch of inputs, we get outputs, and we measure them. We say, is it good or bad? And if not, we say bad robot. Then it goes back and rewires itself and then tries again, right? Like a really reliable little dog that just wants to please you. But you do this 10,000 times. So this is a neural net in here. We'll talk about the specific. That's a neural network. That's a decision tree. That's some machine learning kind of component in here. But the same idea is that we apply a bunch of inputs, get a bunch of outputs, and we tell the system whether it was correct or not. That sounds like the functionality of a tester, like a human tester, right? So this machine learning is super, super applicable to the problem of testing. So what's inside that black box? You'll see lots of pictures like this on the internet. We don't have a time to go through a grad level course on machine learning and neural networks. But essentially this is what goes on inside that black box, right? There's one or more inputs on the left-hand side. And inside there's a bunch of hidden layers. And all these little things, all they do is add up the inputs that are coming into them and produce a sum on the other side. It goes into another layer of these adders, right? These accumulators. And then they produce an output. So realize this is really simple stuff, because what you do is you have a bunch of examples of the input, right? Pictures of hot dogs and not hot dogs. And on the output you have, this is a hot dog or this is not a hot dog, right? They're really dumb. You train on 10,000 pictures, right? And guess what it will eventually do? It'll figure out how to classify it correctly, right? Like kids learn faster, but not that much faster. But after 10,000 iterations, this network will auto-configure to recognize hot dogs versus not hot dogs, right? But again, this is inside the black box. You don't need to worry with details. But the idea is pretty simple. You apply inputs, and you have expected outputs. And you say good bot or bad bot. And it learns. So how do we teach it? Let's get practical, right? By the way, why don't we put like low-pass filters on these mics? Anyway, so how does a bot learn to tap and swipe like a person? You go, how could it possibly happen, right? I've had people email me about the course and why I'm working on this stuff, and it'll never happen. You'll never be able to teach a bot to do this, right? The real story is it's pretty easy. Because guess what we do? We just need a bunch of examples of input and what humans would do on the output, and then we can train a machine to do it using machine learning techniques. So what did we do? We got a bunch of input examples, right? So in this example here, you can see there's a mobile app screen. It's got, sorry, I'm really having difficulty trying not to scare everybody with that. So it identifies there's a hamburger button menu here. There's a login button, a sign up button, username and password, right? You guys, even from the way back, you can probably figure out what kind of page this is just by squinting and looking at it, right? Looks like a login page. Right? How do we teach a machine to recognize this as a login page? Well, what we do is we show them 10,000 examples, just like this is a hot dog and this is not a hot dog. We show them this is a sign-in screen and this is not a sign-in screen. Like 5,000, 10,000, 30,000 times. And the network learns, right? And the way we translate the visual image that we look at and translate into our brain, the way we teach the machines to do this is we convert there's a bunch of different techniques, but essentially we take the DOM of the application and we apply things to the neural network like how many text boxes are in there, right? How many like images. We apply all those things into the neural network, and the neural network figures out what's significant and not. We don't teach it. You just show it the examples and it figures it out. So we have to convert this real-world thing, which is an app screenshot and a DOM, into something that the neural network can understand, right? And that basically floats. It's numbers or integers. So we can train on this input. Now how do we teach it to tap intelligently like a human? What we do is we show them a login page and tell it, hey, yo, this is a login page, robot. That's a hint. And secondarily, we say, what do you want on the output? There's an output for every element on the screen. And that output tells us which gesture the bot wants to take. Now when we initially train it, it's randomized. So we'll say things like, I want to do a pinch on the hamburger button menu in the upper left corner, right? People don't do that. So we say dumb robot, right? When it says things like, hey, I want to tap on that hamburger button menu, we say good robot. And again, we do this with thousands of training examples. So we've taught it really quick, pretty easily, I think pretty intuitively. We've taught it how to recognize, this is a login screen, just like we teach it the cat or a dog or a hot dog or not a hot dog. And then for every element on a screen, you start to teach it, this is what a human would be doing with it, this is what a human tester would do with it, and this is not what a human would do. So don't do these other things. And what you end up with is a network in the middle here that's now trained to behave like a human. And when you look at it, it's really kind of like a 5-7-year-old kid, to be frank, right? It can load an app, it can start, if you watched it, if you just watch it, you couldn't tell if it's a 5 or 7-year-old or this neural network running and walking through the application. This neural network can also, get more details, they can sign into an account. Sometimes it creates accounts, not all the time. It'll go in, it'll watch movies, it'll play shows, it'll go in and fill in, date combo boxes and sign up for stuff. So what we've done is we created a neural network to actually test an application. And again, this is the happy path. This is the question I get a lot. Well, that's easy. Well, yay. When I got this running right, I was like, yay. But then people like, testers are like, well, how do you make it break the app, right? Well, then what you do is you start to train a different brain that's a negative brain, right? And you train it like, hey, yeah, pinching on the hamburger button menu, kind of a good idea, right, for boundary cases. Like test input for an email field, yeah, good robot, you try to string without an @ sign in it, right? So we can train it to be also like negative, do negative and boundary tests and so on and so forth. You kind of imagine. Does this kind of make sense to people? Or is anybody willing to say that they don't get it? Okay, yeah. Is there any aspect of it that, yeah. Yeah, so the question is who's training the robot what's good and bad, right? And it's actually as horrible as you imagine. It's exactly that. Look at this in a second. So yeah, so almost all this machine learning and stuff, the algorithms are pretty simple, relatively simple. The problem is getting the training data. So we actually went out and we did, start with this screen. You want to turn to the next slide, which is we show a bunch of screens. So we basically built some really cheesy automation to go out and automate about 30,000 applications. You download them from the App Store, take screenshots automatically, and then we send them off to Mechanical Turk, right? So we've got, I think, I remember now. I think we have 100,000 or 200,000 screenshots. I think it's 200,000 now screenshots taken from the applications, from all different sorts of applications. So like here's one that has a dialogue, happens to have dialogue on it. And then we run them through Mechanical Turk. People familiar with Mechanical Turk? Yeah. So you just send these pictures to people on the internet. They get like, I think they're getting paid like 20 cents a label at the end of the day. So for 20 cents, you can pay a human to say, okay, what is this screen? And then what does it look like? So is this a pop-up menu? Is this a home screen? Is this login? Or is this whatever? This is one of our first versions. So we built this little web page. It just hosts and runs through all those screenshots. And then we have humans with some oversampling label all those screenshots. So really just brutal, brute force. Yeah, it's actually kind of feels stupid. It's exhausting, but thank goodness for Mechanical Turk. But then we get all these labeled data. So we have the input. On the left-hand side is the screen, right, with the DOM and everything behind it, the screenshot. And then the right is the output of what humans labeled it. So you know, hey, this is a login screen. This is a pop-up dialog. This is a permissions screen, that kind of stuff. So it's just brute force, tons of data to train it. Does that make sense? It's almost embarrassing. Yeah. Beautiful question. Yep. Yeah, so the question is, if you went to test.ai, okay. I'm sure you have to go to www.test.ai because you can't figure out the email. But there's nothing there now. It's just a sign-up thing for beta, to be clear. I hope to have a downloadable framework we can run locally on your own app by Halloween. That's what this framework is. But today, so the question is really, when you download this framework, you use this framework, do you have to go and train it, right? So out of the box, you don't. Because what we've done is we've taken, the slide I think in there, but we've taken over 500,000 samples of buttons and elements and pieces of pages too, combined with the 100,000 or 200,000 just screens. And so we've trained the neural network. We've trained a general neural network that's kind of like a human that generally, if it looks at an app, it kind of knows what those things are, right? So it'll pretty consistently identify login screens. It'll pretty consistently identify hamburger button menus, and these types of common elements and applications. If you have some interesting widgets though, so out of the box, that's the classifier that runs against your app. And you can write test cases without doing any custom work at all, just by saying like, go to login screen, username, password equals whatever, go to the shopping cart, go to whatever. It'll navigate through these general, nouns and verbs to the application. So you train this general purpose network. If you have specific things in your app, or there's specific labels in your app, like you've got a magic checkout button, or hey, someone here is building apps to control autonomous planes, right? There's like a land now button, right? That doesn't exist. It's not very common. What you do is you load up the app. This is actually a screen that for a labeler. Our app with a bot crawl your application, but then you can go in and just add custom labels. You can click any screens and add a custom label to it, and then the bots will automatically relearn and retrain on that. So you kind of build your own custom vocabulary if you want. Out of the box, it just works very generically, but if you want custom stuff, you can label it locally too. And then the machines just train themselves. Any other question on that stuff? Yeah. Yeah, so you're saying, trying to figure out, like, do you use the, wrong direction. Use no slide symbol. Here, sorry. I was trying to show this here. Horrible diagram. So the question is, how do we correlate, I guess, how do we correlate the screen bitmap? How do we train on both the bitmap of the screen and the DOM of the page, right? The reality is with neural networks, you don't know what's going to be significant or not. You kind of just funnel it all in. This is the easy way to do it. So you basically convert, the easy part is the DOM. Like I was trying to say earlier, you do simple measurements, like, so how many div tags does it have? How many text boxes does it have? How many times does the word login appear, right? That kind of stuff, 0 or 1. You feed that into input to the network. You also, at the same time, can feed in things from the bitmap. A couple of good examples make it real too is that one is the average color of the screen, the average RGB. That's a pretty useful signal, it turns out. Think about Facebook login. It's always blue, and it's always has the same number of DOM elements on it, right? So that's really good at that. We also do things like there's some other, like I can talk offline about it, but it's we also do some image recognition stuff. So we sit on top. We actually feed some image recognition stuff before we feed into the network. So we have things that will actually do boundary detection in the screenshot, and we'll put things like the count of the number of elements that the boundary detection detected, those kind of things, into here. And again, we feed all that data into the network, and then we just have a lot of data, and we train it a lot of times, and it converges. And it figures out what are the significant bits. So for some classifications, the screen doesn't matter. For some, the DOM doesn't matter. There's another question in the back. Yep. Yeah, so how does it handle like more complex apps, like a Windows 10 or even like a desktop web page? So for that exact reason, that's why as a company I'd make the decision we started to focus on mobile first, because the UIs are just simpler, smaller, cleaner DOM. A button is usually a button, not a div or an image map or something stupid like that. So we constrain the problem. So to answer the first part of this part of the answer, this is a confusion matrix. So this shows you how confused the neural networks that you build are, or how not confused they are, right? So if this was, everywhere this is white, or it's a 0 entry here, so this is all the different labels. So this is like login screen, pop-up, overlay, whatever. And then the same list is along the bottom. So everywhere in here, where it's light and white, means that there are no misfires. There's no misclassifications. So false positives, false negatives, and the like. So when we got to around 300,000 training instances, we started getting this almost clear, meaning we very rarely made mistakes in classification on the simple mobile app DOMs. The answer about, man, I think I lived too close to Canada. I said about almost. But when we've actually already started working on desktop web, not desktop native apps. And the funny thing is, I thought I was actually more intimidated by that. I thought it'd be problems and problematic. It actually works just fine. Really, because we have a lot of data. and the nets just figure out how to do it right, because we combine, partly also because we combine both the screenshot and the DOM of the application. There's enough signal. It's actually, in a weird way to think about it, it's more signal than the human brain actually gets. The human brain, as a user, doesn't even get the DOM, right? They get the UI screenshot into their visual cortex, but they don't get access to the DOM of the application. So networks are actually amazingly stable and converge, far better than I thought I would, even on large desktop web apps. But I haven't worked against Windows 10 desktop. Did you say Windows, you said, right? Yeah, I heard. No, I'm kidding, sorry. Okay, cool. Yes, we haven't done against desktop apps yet. But I think it'll be, I think the complexity is on the order of, based on experience of the desktop web apps. So, should be good. We'll see. Yeah, quick question.
How do you make the jump
How do you make the jump between
you train
Yep.
Isn't that going to eventually have thousands of that, what is correct and what is incorrect before it actually learns?
Sorry.
Learn to make, I can figure out what this does or what it should do just based on how what it's looking.
Oh.
The difference itself.
Yeah, so we're pretty dumb. I think. So I guess if I can rephrase the question, it's how do we? If I can infer the question correctly, it's for everything we want the bot to know is good or bad or what to do or not to do, you have to give it thousands or tens of thousands of examples, right? I think it doesn't scale very well. So like, how do we get it to start thinking and recognizing more meta things, right? Like this is generally a good action to take on an arbitrary element. So we have one way to do it. It's a little bit nerdy for this. We only have 40 minutes or something. But I'll say the nerdy answer is that we don't do it. We don't do a really, really smart job. We don't have a brain that knows how to generally just use an app end to end, all in one single neural network, right? We don't have that. You have one, but we haven't built one in here. What we do though is we abstract also these comments. So for every action, for every element type, we also save off. We'll save off things like we'll build separate neural nets for every size of element, and by the way, for every element in a particular app category as well. So we train different nets that are trained at different levels of abstraction. So is that a hamburger button, or is that a hamburger button, or a login button, or whatever button? You basically pull all the button types out and also train on that, so it knows how to generalize how to interact with each button. But if you gave it a picture of a beach and sand, it wouldn't know what to do with it. If that makes sense. We just abstract it enough, because I'm a very practical person. I'm trying to get the shit to test case, to run test cases. But does that make sense? Does that answer it, kind of, or are you just being nice? Both, I guess. So, I don't think anyone in the room has seen this app. But anyway, so this is the exploratory bots running on a real-world app, right? So this is just a flow in the application, right? So it's in here, it types in some login information, it clicks no thanks, I don't want the push notification to me, and it looks at upcoming trips. And it keeps walking through the application, right? The idea I want to share with you is that these exploratory bots are useful because they're using the app like your users are using them, right? Generally speaking. They also, the cool thing is you can spin off thousands of these, right? You can spin up 200 of these in an hour after your build, all running in parallel, and give you data and results back. So you can detect crashes, you can detect performance problems, you measure performance, how long it takes the page to load. And almost every time you find a problem in here, when you look at it, you go oh, that's one of my users is probably doing that kind of a flow, right? And again, there's no code, no customization. It just runs through an application. So it gives you a lot of coverage out of the gate with no code, literally no code. And many app teams spend 18 months building a framework to just to be able to drive the app in the future for test cases, right? Out of the gate, we've actually run this level of testing on almost 30,000 apps at this point. So if you have an app, we've probably already tested it, by the way, which is pretty cool. Cool. Is that looking up? Okay. Yeah. So that's exploratory testing, right? And we can do it at scale. So we've run millions and millions and millions of tests. Here's the performance breakdown. The other thing these bots can do that most people in here don't even do with their own app is it measures the time loading of every page in their application. So the bots can immediately tell you that over all the samples I've taken, this is the slowest transition in your application. You can also show you the distribution of all the timing in your application, right? So, like, is this really slow and everything else is fast, or is everything kind of slow? But more importantly, you can't see it in the back, but trust me, there's actually a number here. The awesomest one to me, as a tester, it's part of the benchmarking story, is that there's a column here that says other apps in your category, in travel and leisure. Because we've crawled all these other apps, we can tell you this app's performance is on average, 220 milliseconds. But guess what? The average transition in that category is 120 milliseconds, almost half, right? So does that team, and should that team care about performance? Probably. What we find is that this benchmarking ability motivates teams to actually care about performance, right? Because you point to the competition and you say we're lagging. So let's talk about regression testing. So this is what everybody wants. So I go out and I raise money, do all this hard work, and everybody goes, cool, robots, they magically walk through my app. That's freaking awesome. But can you run all these test cases in my spreadsheet? I literally want you to run the ones that is exactly typed out in my spreadsheet, right? There's 200 or 300 or 1,000 test cases. And they have special text in them, they have special paths, and they're the experts in their application, right? They want those to be executed. So I had to go back to the drawing board and wanted to build that out. So we kind of answer the full testing problem. So the goal was this. The goal was to replace, so a typical system, you write your Selenium script, it talks to Appium or Selenium or UI Automator or whatever the platform is, and drives the application, right? What we want to do is take a net, build a net, right, that will replace your custom test scripts too. And then execute them against Appium and Selenium and against your app. So really what we're trying to do is replace your brain as a code testing scripter with a neural network that's trained on your specific test cases, which is kind of crazy. So you can throw out all your custom regression tests and give it to the bot. So there is still an intermediate step you have to perform. You have to convert your test cases to this format. We're calling it the AIT format because it kind of abstracts the intent of the test case. But most of your test cases, if you think about them, there's a linear set of things you want to do in the application. Sometimes you care about the exact order, sometimes you don't. And you want to apply specific inputs to elements, and you want to verify specific text or elements are on a page when you get to the end to verify the test case, right? This kind of subsumes about 95% of all Selenium scripts I've seen. We've also worked with about 25 different companies, pulling in all their raw test cases, going through their spreadsheets. It's really awesomely exciting, and figuring out what the requirements are to satisfy all these custom regression test cases. But this is all really people are doing. The reason you write all that Selenium code and all that Ruby or all that C# or all that Python code is because you have to tell the machine how to execute this stuff, right? And you have to tell it how to recognize what part of the app is. You have to tell it where that hamburger button menu is, and you have to tell it what kind of input you want to give to it. So you're spending all your time hard coding all those scripts. So what we're trying to do is build a brain that abstracts from that, right? This is the most minimal representation of a test case that we could come up with. And like you saw earlier, we can feed that directly, those test scripts, directly into the AI, and the AI parses those scripts, loads up your application, looks and sees everything in your application, classifies all the buttons and elements, figures out what page you're on, and then applies those inputs and drives the application, right? And it's cool enough that when you also send it, say, hey, I want to go to the cart page, it knows how to get to the cart page because it looked at all these other apps and it knows, hey, guess how you get to a cart page? Like everybody else in here does. You click on the cart button, right? That's 90% of the time the quickest way to get to the cart. And the bots know this. We've trained it on this with excruciating numbers of training set samples. So the coolest thing that goes on here, so you think about regression testing with AI, is you don't have to write all these stupid, I won't say the word damn, element selectors, right? They keep changing and breaking build to build. You don't have to work with that. You have to look at the resource ID or say it's the XPath or the parent-child relationship of something. We can look at it on the screen and the bots know what it is already. You just have to tell it which ones you want to sequence in the test. There's no element selectors. Also, there's no flow hard coding, right? You're not saying go here, click here, go to here, and all these setup tests and steps and stuff. You just tell the bot, I want to go from here, and then I want to go here. And guess what the AI does? It takes you from A to B to C, applies an input, and then verifies an output. But you don't have to explicitly tell the AI how to do it. So what this means is that you can write test cases, like that little, you just copy paste that little file. You can write a test case in like 10 seconds and create a variant of it in 10 seconds. Copy paste and change it and create, like, say, instead of verify the, instead of go to the cart, go to the profile page and just say profile, right? And the bots will get there. They'll take you there. Old song, I'll take you there. But the bots will take you wherever you want in the app, right? They'll drive the application. They'll verify the behavior. So really, we're really with AI. Beautiful thing is we're taking what used to be, a month worth of work and compressing it down to about 24 hours, like literally to build an interesting, relevant test suite. Yeah. The question is, can you use Chrome, or is the intention to use Chrome or even other instrumentation to record what users are doing and then generate test cases from that? Oh, you're trying to get me in trouble? About recording data in Chrome? Are you trying to get me in trouble, like with privacy stuff? So are you saying that you could? Could, yeah. But like I guess I'm insinuating is there's also a fair amount of PII involved in that. The hardest problem with recording production data and playing it back, we've thought about doing this, is that we need to really make damn sure we don't record people's social security numbers or any other identifiable information. And I've been spanked and learned from past contexts at Bing that, like, even if you scrub all the IPs and everything, stuff is still personally identifiable in a lot of cases. So I've steered completely clear of that model. Yeah. You could use that as training data. Absolutely, if you can have it anonymized and you record it kind of a standard format-ish thing. The interesting thing, though, too, is that I'm focused on emulating testers, not users necessarily today, right? Like regression tests are really about, so for the exploratory bots, that's interesting training data for, but for the exploratory bots, you really want to instrument testers. That makes you think about record and playback, and that's a dirty word to me. So really what I want to do is just have a conversion process directly from your regression scripts, and then so you don't have to have a lab. Like you'll execute this stuff in the cloud too if you want. So you don't need a lab, you don't need an engineer to code up all the Selenium scripts, you just have those high-level descriptions of steps. But that's a very different thing than what users will be doing. So even like negative test cases or boundary test cases. Yeah, that's a good idea, I'm not smart enough to know how to do it. I know just enough to know that it's dangerous. Sorry? There's a whisper. Okay, yeah, sorry. Ah, that's a beautiful question. Yeah, so how hard is it to maintain it? I think I paid her to, it's your plants, right? So that's the beautiful thing. So guess what happens? You wake up tomorrow and your hamburger button menu is pink now, right? But your hamburger button menu is now a bitmap image. It looks exactly the same, and it takes a tap instead of a click on a button like it did before. The bots will still go to the hamburger button menu. They know what that's still a hamburger button menu. So the tests are not brittle. Usually the biggest problem with Selenium tests, pick on Selenium, is that the very day you need Selenium to regress your app is the day that they're all toast and broken, right? Like you write all these scripts to regress your test, they change the application, they change the flow, they change the selectors and the DOM properties, and you go, hey, does it still work? Guess what the automation engineer says? I don't know, I'm debugging all the breaks, right? For 36 hours, while the manual testers say, yeah, it still works. So thanks, automation people, right? The beautiful thing here is that at runtime, the bots are evaluating what's a hamburger button, what's a login screen, and so on. And they're also going, hey, I want to get to the cart. So if you remove that cart image even, right, they'll still know a great way to get to the cart is to go to a product entry, right? And usually on the product pages, there's an add to cart or buy button. And that's a great way to get to the cart. So they're actually very, very, almost too adaptive in terms of how they'll be resilient to keep running the test cases with the intent of the test case, despite product changes underneath. Does that make sense? Sorry. Kind of a step ahead. Yeah, and by the way, in a funny way, it's actually not even, in a weird way, it's a step backwards. Because what it's doing is it's what doing a manual tester would do, right? If the manual tester picks up the new build and the UI is changed a little bit, they don't freak out and cry, you know? They don't have a panic attack. They go like, oh, the developer removed the shopping cart button, but I still want to get to the shopping cart and test all that functionality. I'm going to figure out a different way to do that. So it's really, in a weird way, it's just embedding kind of that intuition and the knowledge across, tens of thousands, hundreds of thousands of apps, and putting that into the neural network so the bots behave much more like a human, rather than a hard-coded regression test script. Cool. So we're almost, I think we've got 5 minutes, 3 minutes. So I'll say this, so why am I wearing the shirt? Because it's awesome, because somebody paid me to. No, so we're going to have I work at Appdiff, but we're doing a branding change because this is pretty directly obvious what we do. We do testing and we do it with AI stuff. So it's test.ai is the URL and logo. We hope to release a download that's like Selenium-like. May not even have Selenium in it at all by that time, by Halloween. It'll be available at this URL. So you can download that, point against your own mobile app and or mobile web page, and watch the bots run and try to create some regression test cases. We hope that's available on Halloween. The only reason it won't be available on Halloween is that I've been in testing and QA a long time in my life, and so I've hired a bunch of QA and tester people, right? So they find all the reasons I shouldn't release it. So we're trying to figure that out right now. But hopefully we'll have something, and it may be qualified, I guarantee it be qualified with some alpha or beta logo on it, and it may only be installable on a clean Mac OS machine, like a Mac Mini or a Mac Pro to start with. But we're really hoping to have something downloadable by Halloween that people can play with. But real AI running real test cases on your local machine. That's the picture of our output. Think. Blah blah blah. Okay. Is it free? Yeah, of course. Venture capital, huh? No. So this is Silicon Valley. Just make up for it and use it, right? So to be very open about that, like so our business model would basically, and things will change or could change. So this is non-binding, but the current thought is, because we're early, I want to get a lot of feedback and make sure this stuff actually works for real world with real people, and real people can actually do it themselves. So we're going to download it. It will not have the ability to do like a Selenium grid, right? If you want to run 100 test cases in parallel, by default it won't have that kind of functionality out of the box. But you'll be able to run test cases in serial on your local box and have it all. So the goal is that the downloadable client will service an Agile team, so they can take it, like in the 2 days you have to test your damn app in an Agile cycle, a sprint, you can download the damn thing, add some test cases, get some basic coverage before you ship it. And you can do that all free and try it in the world. Where we make our money, there's a company called Foss Labs, it's way cooler than I am. The thought is just that we will do, we'll have two things we're paid. So if you wanted to execute it on our cloud, old company. If you want to run on our cloud, we'll charge you for that because the machines aren't free. And we'll also have probably bigger, better brains on our end. And we also do custom enterprise stuff. So you can just send us your nasty spreadsheet or Word doc, and we'll take care of converting all that into automation because it's so cheap and easy with AI stuff. But we'll charge for that stuff. So if you're an enterprise, yeah, if you're a little tiny dev shop where you have, you're just running sprints, you want to try it out and play with it, all those scenarios should be free. Until I'm kicked out, another CEO wants to charge the hell out of everybody. Oh, and actually to that point too, I also intend to be slowly, as much as I can, as we get the code cleaned up, to open up this platform as much as possible. So you actually swap in your own networks, your own AIT scripts, and your own logging and reporting stuff. So it's kind of a modular structure to be documented. Cool. I'm out of time. Anyway, hey, pretty cool you guys saw AI actually executing a freaking test case, right? Go tell your mother. I appreciate it. Thanks, guys.